Unit 5, Section 4. Differentiation of exponential and logarithmic functions. Session objectives. By the end of this session, the student will be able to 1. Differentiate exponential function in any form. 2. Differentiate logarithmic function in any form. Differentiation of exponential function. Exponential functions always take the form e exponent g of x, or f of x equals to a exponent g of x. Now the g of x, or the exponent, is a function of x which is differentiable. The g of x can take any form, but in this our case we limit ourselves to polynomial functions. By definition, if exponential function is given as f of x equals e exponent g of x, then the derivative of f of x is e exponent g of x multiplying the derivative of the exponent, that is the derivative of g of x. Now, if we are given that our g of x is x exponent n, which implies we have f of x equals e exponent x exponent n, then the derivative of f of x is equal to, you find the derivative of x exponent n using the power rule, which gives n multiplying x exponent n minus 1. Then we use it to multiply the given function, which is e exponent x power n. Differentiation of exponential function. Example. Let's differentiate the following exponential functions with respect to x. A, f of x equals e exponent x. B, f of x equals e exponent 3x plus 2. C, f of x equals e exponent 2x exponent 3 minus 1. Now, for A, our g of x is x. So since we know the derivative of exponential function to be the differential of the exponent times the given function, then we differentiate g equals to x, which gives g of x to be 1. Now we use that one to multiply the given function e exponent x, and that gives the derivative to be e power x. For B, let our g of x, which is the exponent, be 3x plus 2. Then we differentiate that exponent, which gives 3. That is the derivative of g of x is 3. Then we use that derivative to multiply the given function e exponent 3x plus 2. And that gives 3e exponent 3x plus 2. For C, that is f of x is equal to e exponent 2x exponent 3 minus 1. We find the derivative of this exponential function by equating the exponent 2x exponent 3 minus 1 to g, or we let g to be 2x exponent 3 minus 1. Now, differentiating g with respect to x, that gives 6x squared. Now, to find the derivative of f of x, then we multiply the derivative of g of x by the given function, and that gives the derivative of f of x to be e exponent 2x exponent 3 minus 1 multiplying 6x squared, which gives 6x squared e exponent 2x exponent 3 minus 1. We also consider the derivatives of the functions in the form f of x equals a exponent g of x, where the g of x is a function of x and is differentiable. Now, by definition, to find the derivative of that function, a exponent g of x, the derivative of f of x is equal to a exponent g of x multiplying the derivative of the exponent times ln a. So now, given that g of x equals x exponent n, then to find the derivative of f of x, we differentiate g of x, which is equal to x exponent n, and that gives n x exponent n minus 1. Then we multiply that by ln a, then multiplying the given function. So to differentiate the exponential function a exponent g of x, we differentiate the exponent, multiply it by ln of the base a, then use it to multiply the given function. Differentiation of exponential functions. Now let's differentiate the following functions with respect to x. A, f of x equals a power x. B, f of x equals a power 5x. Then C, f of x equals 5 exponent 3x squared plus 1. These are exponential functions, but in another form, not the base e, but rather a and 5. So, to differentiate a, f of x equals x exponent x, we let our g of x to be the exponent x. If we differentiate g of x equals to x, that gives 1. Now we multiply that 1 by the ln of the base, that is a, so that we have 1 ln a, which is used to multiply the given function, and that gives a power x ln a. B, for f of x equals a exponent 5x, we let g of x to be 5x, so that our derivative of g of x equals 5. Now that we know the derivative of the exponent 5 of 5x, let's multiply 5 by ln of the base, which is a, so that we have 5 ln a. Now that 5 ln a is used to multiply the given function, and that gives a exponent 5x times 5 times ln a, which gives 5a exponent 5x ln a. C, the function f of x is given as 5 exponent 3x squared plus 1. Now, to differentiate this, we let g of x to be the exponent 3x squared plus 1. Differentiating the exponents, that gives 6x. Now, we multiply this 6x by the ln of the base. In this case, the base is 5, so that we have 6x ln 5. Now, we use the 6x ln 5 to multiply the given function, and that gives 5 exponent 3x squared plus 1 multiplying 6x multiplying ln 5. Differentiation of logarithmic function. The logarithmic function and the exponential functions are inverse functions to each other. So that if e is raised to the power ln x, it gives ln e to the power x, which is equal to x. Ln e to the power x is equal to x because the base for that log is e. And in logarithm, the log of any number to the same base gives 1. So applying the third law, x ln e base e will be x. Now, by definition, if f of x is given as ln g of x, then its derivative is equals to 1 over g of x, multiplying the derivative of g of x. It means if you are given the function to be the ln x squared, then its derivative should be 1 over x squared times the derivative of x squared, which is 2x. Now, if the g of x is taken to be x to the power n, then the derivative of this function is the derivative of f of x equals 1 over x power n, multiplying the derivative of x power n, which is n x exponent n minus 1. Differentiation of logarithmic function. Example, find the derivatives of the following functions. A, f of x equals ln x. B, f of x equals ln 3x. C, f of x equals ln 5x cubed. D, f of x equals ln 3x exponent 6 minus 2x. Now, solution. Using the definition given, then our f of x equals ln x, we let g of x to be x. And we differentiate the g of x with respect to x, which gives 1. But we saw that the derivative of f of x, if f of x is given as ln g of x, is 1 over g of x times the derivative of g of x. So in this case, our derivative of f of x equals 1 over x times the derivative of x. The derivative of x is 1, so we use it to multiply 1 over x, which gives 1 over x. B, we have f of x equals ln 3x. And by definition, we let g of x to be 3x. So the derivative of g of x is equal to 3. But from the definition we learned earlier on, we saw that the derivative of f of x, if f of x is equal to ln g of x, is 1 over g of x times the derivative of g of x. So the derivative of f of x is equal to 1 over 3x. Since our g of x is 3x, that times the derivative of 3x, which is 3. And if we multiply 1 over 3x by 3, it gives 1 over x. C, f of x equals ln 5x exponent 3. In this case, we let our g of x to be 5x exponent 3. When we differentiate 5x exponent 3, we obtain 15x squared. Now, the derivative of f of x equals 1 over 5x exponent 3 times its derivative, which is 15x squared. If we multiply the derivative of g of x by 1 over g of x, then we have 3 over x. D, the function given is f of x equals ln 3x exponent 6 minus 2x. So we differentiate 3x exponent 6 minus 2x, which gives 18x exponent 5 minus 2. Now, the derivative of f of x equals 1 over g of x, which is 1 over 3x exponent 6 minus 2x, multiplying its derivative, which is 18x power 5 minus 2. So multiplying, we have 18x power 5 minus 2 all over 3x power 6 minus 2x.